Hello everyone, this is the Oasys FAST-TCF introduction webinar. My name is Sundip Shah and I'll just be going through this webinar with you today. So the outline of the webinar is as follows. We're just going to go through what FAST-TCF is, how to generate a FAST-TCF script and how to use it. We've got a couple of demonstrations to give you. We'll go through text editing a FAST-TCF script and running the FAST-TCF script in batch mode. Okay, so what is FAST-TCF? It is a quick way to reproduce plots from THIS. The FAST-TCF is actually a scripting language for THIS, and what you can do is you can use it to automatically generate your THIS plots with a few clicks. The script itself is a text file and it's readily editable. It contains all of the information to set up and position a single graph or multiple graphs. You can read in data, perform all of your curve operations, and generate the output that you need. The scripting language is straightforward, and even a novice can edit the input file manually. You can use the input file in batch mode to automatically post-process results from several models, or you can use different FAST-TCF scripts and batch process a single model and obtain many different types of results for that same model. Okay, one of the questions that we're often asked is, what is the main difference between FAST-TCF and JavaScript? So FAST-TCF scripts are automatically generated from THIS, and they're used to reproduce or automate your LS-DYNA results plots. The whole language is written by Oasys. The scripts itself are easily understood. You can use the THIS manual in section 7, and you can also easily edit it yourself. JavaScript, on the other hand, is a coding language in its own right, and Oasys only adds on an API which allows JavaScript to interface with the Oasys software. So with JavaScript, you need to write your own scripts, and you can certainly do that to perform specific tasks. JavaScripts have more advanced functionality, but the downfall is you have to write them all yourself, whereas the FAST-TCF is generated automatically. Okay, so let's move on to how to create a FAST-TCF script. It's very easy, and actually what you need to do first is read in your LS-DYNA model, read in the data that you require, manipulate the curves in the way that you want. You can perform any operation you want. You can do multiple operations if you like. Once you've obtained the curve that you want, you can then format the axes, change the curve names, the titles, and so on, colors, make the plot exactly how you wish it to be. And then the next thing to do is go to the FAST-TCF menu and create the FAST-TCF file. What you can do at this point is you can automatically so you change the file name and create your FAST-TCF script. You can run that on the current page, so effectively that will reproduce the plot that you have for your current page, your current graph that you're showing. You can do that for all of the pages if you have multiple graphs, and we'll do a little demonstration of that later. At the same time, you can also request an image output and a curve output of the graphs that you wish. So the script itself is saved as an INP file or an input file. Once you've done that, you can then run your scripts just by in the FAST-TCF menu, and we go to the Run menu. You read in your script and you can play. Now, an important thing to note is that you must have read in your LS-DYNA file beforehand before you can run the script. Otherwise, the script doesn't know which data you want to run the script on. Okay. Now we've got some feedback windows here that are useful for debugging. You can also step through your commands one by one, or you can play them at full speed. Okay, so we're going to go through the first demonstration now. So what I'm going to do is I'll just close this THIS. I'll open another fresh version of THIS, and I'm just going to open a results file. So bear with me, the network is a little bit slow. We're going to demonstration 1, and I'll just read in the results file there. Okay, so I've read in the file. What I want to plot is the contact time history for this particular contact here. So I'll click on apply. We've got that time history there. Now what I want to do is apply a filter to it. So we can just apply that filter. So you can see in red, there's the filtered curve. It's the C180 filter. Okay. The next thing I want to do is perhaps just show just my filtered curve. And perhaps I want to show the maximum value on the curve. So go to properties, curves, and then highlight and show the maximum. And that will give it to me there. Okay, maybe I want to change the color of the curve. So let's go to blue. If I want to change the title axes, I can just change it there. Maybe I'll call it contact force time history or something like that. Anything you like. Maybe I want to add in the units. So I can just left click and add the units in. Okay, and the other thing I might want to do is just change the name of the curve itself and perhaps give it a more sensible name. So let's call it something like that, contact force magnitude seatbelt to dummy, and we'll say it's a C180 filter. Okay, so that's all fine. So what else can I do? Maybe I can add some grid lines in, and I can always change the foreground and background color if I wish. So that will all be captured in the FAST-TCF file as well. Okay, so I'm happy with that now. I'll generate my FAST-TCF script. So let's call it contact force. Okay, there we are. I want to output the current page as it is. Let's also have an image output, and I can also output the unblanked curves. So I'm saving the image as a PNG file, and the curves obviously will be a CUR curve file. Okay, so I've set up everything. I'm happy with that, and I'll just click on apply. Okay, so I've actually created the FAST-TCF script. Now, what I'm going to do is I'm just going to open up that file. You can use a text editor, any text editor you like. So we can see we've got the file here, everything in blue with a hash there. That's all. That's a comment. So that's just there to help you, or you can just add in your own comments if you like. If we scroll down, we can see the commands that have been performed. Okay, so I'll just minimize that for now. I'm going to open up a new session of THIS. And what I want to do is I want to read in a different model this time. So I'm going to read in run 2. So just bear with me while the network catches up. There we are. So we'll read in run 2. Okay, we'll read in the THF file there. Now, this time I don't need to select anything. I can just go straight to FAST-TCF and click on run. Okay, so I actually want to run this contact force. I'll just copy it there, and I want to run this file here. Okay, I'll click on play, and that's generated the FAST-TCF script. That's generated the plots exactly how I wanted it, but run on a different model. Now, the thing to bear in mind is your new model must contain the data in order to generate this script. So in this case, it must contain the contact between the seatbelt and the dummy. So it has to be able to read that in, and then it can manipulate the data in order to format it and plot it in the way that you've requested from the FAST-TCF file. Okay, so the next thing perhaps that I'd like to do is show you how to manually edit the FAST-TCF file. Okay, so what you can do is change the operation here, and you can see the list of operations in the THIS manual. So what you can do there is change the filter from a C180 to a C600. Okay, so we can do that. We can also change the titles. We can change the colors. Okay. Now, by default, the output, so in this case, the image and the curve file, are output into the same directory as the FAST-TCF script. Wherever the script is stored, that's where the output will be. So that's not always helpful. So instead, what we can do is we can just add a little wildcard here in, which is $run_dir. And if you put that within the inverted commas, then that will actually output your PNG file and your curve file into the same directory as your model data. So that's very useful. So what that means is that you can have your THIS FAST-TCF files all in a scripts directory somewhere, maybe stored centrally, and you can run them. And rather than having to go to that directory, it will actually save the output files in the run directory. So that's very useful. Okay, so I can save that, and then I can run that. Okay, so that's the end of demonstration 1. Let's go to the next. So now we're going to talk about demonstration 2. Demonstration 2 is opening multiple models. So what I want to do is actually want to open THIS first of all. And rather than single model, I'm going to change it to multiple models. Right, so this is demonstration 2. So I've just clicked on the demo 2 folder, and there's 4 subfolders here. Okay, so I'm going to read in models B1, B2, and B3. So I don't need model B4. Okay, I'll click on apply, So those models are there. Now, what I want to do is I want to read in the kinetic energy for the 3 models. So I can go to global kinetic energy and then all of those 3 models, and that's plotted it there. Okay, now what I want to do is create 3 more graphs. Okay, so they'll form in a grid there. So the kinetic energy has been read in on this one, top left-hand graph. Now, if I just make graph 2 the active graph, so I'll turn off all the other ones, and this time I want to read in the internal energy for each of the models. Okay, and then for graph 3, we'll have the hourglass energy, and graph 4 will have the total energy. Okay, they don't all have to be energies. They can be whatever you like. We're just doing a demonstration using multiple graphs and multiple models to show you that the FAST-TCF script can cope with that. The other thing I'd like to show you is in the curves menu, we can manipulate the curves using the table. Okay, so I can actually go through all of these and just change the line style to a solid line. The other thing I can do is group things, so I can view things here, and I can group by the model. And what I want to do is I want to say model 1 should be green, model 2 should be red, let's say. Sorry, that didn't work. So red. And then model 3 should be blue. So we've got a consistent color system throughout. Okay, so that makes it very much easier to see what's going on and compare our 3 models. Okay, so that's very good. When comparing models, it might be more useful to show the run directory rather than call them model 1, 2, 3. So to do this, we can go to title axis and legend, and then perhaps you can't see that, but we can change the prefix format to the directory. So in this case, we can see it's highlighted /B1 for model 1. Okay, so now we're happy with all of that. I can also maybe add a grid to all of the graphs. I'll go to FAST-TCF, and then I'm going to select all pages. Okay, and this time I'll call it I don't know, global energies. Okay, so I can create the pages there. If I want the script output and if I want the curves, I can output those as well. You can change the file name there as well. So let's do that quickly. Okay, then I can click on apply, and that's done. Okay, so the FAST-TCF has been created. And we're in demo 2, so it's just created it there. Okay, so we're happy with that. The next thing is I want to read in a different set of models. So again, just change it to multiple models, and we'll go to that folder again. Okay, this time I'm going to select a different set of 3 models. So this time I'm going to select 2, 3, and 4, B2, B2, B3, B4. Okay, I'll apply to read those in, and then I'll go to run the FAST-TCF. So I'll just run that, play that through. Okay, so we've got a few more models. It took a few seconds longer, but it was still very quick. We've got all the formatting here as well. So that's really good. Okay, so the thing to note about this demonstration is that we can use the same script with different models, but only on 3 models at the same time, because the script was set up by reading in 3 models. Okay, the output of all 3 models must be similar, specifically the things that you're plotting. So you must output the global energy for all 3 models. Otherwise, you don't have a curve to read in. Okay, if you, let's say you wanted to run it on a different number of models, then you would have to, let's say you wanted 4 models to compare, then you would have to recreate the FAST-TCF script for that particular scenario. The alternative is that the FAST-TCF script could be created for 1 model, and then you just rerun that same script on each of the different models. And then maybe at the end, because you've got all the curve files for the individual models, you could read in all of those curve files and make your comparison that way. Okay, so those are the 2 demonstrations. We'll just go back to the slides now. Okay, so we're going to talk about running in batch mode. FAST-TCF scripts can be run in batch mode using the command line option -TCF. Okay, so this can be used as part of your automated post-processing. An example of the command that you would give is this. So this is calling the THIS executable. This is saying I want to run a FAST-TCF script. So that's the -TCF. And then the equals is saying which script are you running? So this could actually be a file name, or it could be a full path and then a file name. The next bit is saying -exit, which is saying once you've completed running the FAST-TCF script, you can close THIS again. And the final bit is actually saying what you want to perform, which set of results you want to perform that whole process on. And what you can do is you can set this up in a .bat file, which is a batch file, and just double click on that and run that from Windows. And you don't need to have one of these commands, you can have several commands. So I've actually got a bit of an example of that as well, I hope. So if I edit this with Vim, sorry, again, I'll have to just increase the font size. So in this example, everything with the ::: is just a comment, so it's not read in. In this case, I've set a variable to point to a particular directory which has my scripts in it. And then I've set another variable for another script. So you can do that for all of your scripts. The next thing I've done is I've set a file path. Okay, so it can be your run. And the next thing I've done is set a name, which is your file name or your your analysis name. Okay, so this is the actual script itself. So we're opening THIS, we're navigating to the path and the file name .thf. Okay, so that's what we're going to run it on. Then it's FAST-TCF, and this is the name of the script. And I've got a bonus variable here, which is to start in the file path. Okay, so what that will do is that means you can have your script in a different path, but then it will write out the results to the correct directory. And then at the end, we're exiting. So this is a slightly different order to what I've presented, but the commands should be all the same, and the end result is the same. Okay, so you can have several of these in your directory, in your batch file, sorry, and they each can be running a different FAST-TCF script, or you can run the same FAST-TCF script on a number of different runs. Okay, so that's good. So again, just to say that all of this can be found in section 7 of the THIS manual. So that's actually the end of the FAST-TCF webinar. I've just got a couple of slides to advertise the next webinar, which is on LS-DYNA Introduction to Contacts. If you want to register, please go to the Oasys software website. And another advertisement, our next training course for the Introduction to Dyna is a 3-day course which is held in our Solihull office, and it's at the end of this month, 27th to 29th of November. And I've got a personal interest in that because I'll be teaching that course along with one of my colleagues. Finally, please do sign up to the Oasys newsletter. That will keep you informed of all the webinars and all of the upcoming training courses. Thank you very much for listening. So if you've got any questions, please do type them in. That's the end of the webinar. If you have any colleagues, please do pass this on to them. And if there are any questions you think of later, then please do email the Oasys support team, and they can certainly help you out. Okay, so everyone is muted. I can't see any questions here. I'll give it a couple of minutes, but if no one has any questions, then that's the end of the presentation. So thank you very much.